All right, we're going to do add odd digits and count t's. And I'm asking you to do these things recursively. So I've got a bunch of tests up here. You can ignore that for now. Although if we run it, you'll see only one test gives the right answer. They're supposed to get 17, 25, 1. Okay, 2 tests give us the right answer, 0. But not because they know what they're doing. All right, here we go. So let's do the first one. We're going to add up only odd digits of a number. So if we had 1, 2, 3, we would get 4 because 1 plus 3 is equal to 4. We would only be adding the digits that are odd. So what I want to do is say if n is greater than 0, we're going to do one set of things. Otherwise, we're going to return 0. It means we're done with all the digits. And we don't need to add anything else. Okay, now let's say we're in here and let's get the current last far right digit. Int digit equals n modulo 10. Remember, doing modulo 10 gives us the far right digit. You divide a big number by 10 and you end up with the remainder will be the ones place. So now we have the ones place is in this variable digit, and now we can check if that's odd or even, and we're going to do something different depending on whether it's odd or even. So if digit modulo 2 equal 1, that means it's an odd number, then we're going to return digit plus add odd digits, and then we're going to take the number that we're working with here, and we're going to divide by 10 because that lops off the far right digit. Otherwise, we're going to return, we're not adding the digit, so we just return what comes when we call it lopped off. All right, so let's run this. We should get, maybe I made a mistake, but we should get 17 for the top, 0 for 2, 4, 6, 8, because there's no odd numbers in there. And this one, just trust me, I added it up by hand. It should get 25. Okay, so we finished adding odd digits. Hopefully that makes sense to you. If not, look it over and then maybe even try to write it without looking at my answer. Okay, the next one, we're going to count how many letter T's, capital T's, are in a word. So let's start by checking if the length of the word is 0, then we can return 0. So if word.length parentheses equal 0, return 0. So that's our base case. That gets us out of here. Otherwise, we're going to check if the first character, substring 0, 1, dot equals capital T, and we're going to return 1 plus count T's word substring 1. That lops off the first character and goes all the way to the end. You could do 1 comma word dot length, but you don't need to. Just use 1. And the reason we're doing 1 is let's say the word was tiger. We check the first character. Is it a T? Yeah. Then we're going to return 1 plus. And then it returns, when we do substring 1, it returns Iger, and then it'll go ger, and then and then r, and then it'll be empty, and it'll return 0. So we do have to finish this though, else return, and it's this one, and I did forget a semicolon here. Oh, yeah, there we go. So this ought to do it. We'll see. I haven't written it in a year. Yeah. Let's add another test. Counting t's in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 should get 10. I think I don't know, we'll see. I think the spacing could be off. No, it worked great. Awesome. So you don't have to add your own test. I'm just showing you that it's not magic. All right, hope that helped.